The water has left the open world. It now travels inside a conduit that is full, enclosed, and invisible from the surface. Gravity supplied the route into this passage, but a falling surface is no longer enough to describe the motion. In a closed conduit, a difference in pressure or hydraulic head can drive water from one point to another. Pressure is not a single arrow pointing downstream. In a liquid, it acts against the walls in every direction. A small tapping in the wall opens into a clear vertical tube. Water rises inside it, and the height becomes a quiet physical record of the pressure in the conduit. Mira moves beside the column, not as a meter reading, but as water responding to the same field of force. The walls contain the flow, and the flow pushes back. Ahead, the passage narrows. The water is about to change its speed, while the hydraulic story becomes more complicated than one number or one direction. As the conduit changes shape, the water changes its motion. A contraction can increase velocity when the same discharge passes through a smaller area, while pressure and energy respond to the complete geometry. Along a long pipe, roughness and friction take part of the available hydraulic head. At a bend, entrance, exit, or fitting, the flow turns, separates, and rearranges itself. These local changes also consume energy. Mira follows the eddies as they form and fade, while the central stream continues downstream. Then a valve moves. It can narrow a passage, isolate a section, check reverse movement, or regulate pressure, depending on its type and position. Its action is not the same in every design. When the available head is not enough, a pump adds energy through a rotating impeller. The pump does not erase friction. It gives the water a new supply of energy that the rest of the system must still carry safely. The pipe, the valve, and the pump become one moving hydraulic story.
The hydraulic story can change faster than the water parcel seems to move. A rapid valve movement or a sudden pump change can send a pressure disturbance through the conduit. The walls, the water, trapped air, and the control sequence all influence the response. This is why pressure is monitored rather than guessed. Sensors observe selected points, and models can test how pumps, valves, tanks, and pipes behave together over time. No single instrument describes every condition in a network. Farther ahead, the conduit rises toward a treatment facility. The water still carries its source history, but now it arrives with a managed pressure and a controlled flow. Mira crosses the final dark bend and sees the first chamber ahead. The next episode will slow the water down and bring suspended particles into a new encounter: coagulation and flock formation. The pressure story has carried the water here. The treatment story is about to begin.